factoring. For me, it's page 11. It might be a little bit different for you guys in your own notebook. Okay. All right. Once you're there, have that written in on the orange set of notes that you taped in. At the top, I also would like you to write factoring. Alright, so we've talked about how factoring is undistributing, right? It's being able to take out a number or a term that could multiply to make something else. So instead of ending up with the trinomial here, we're going to start with the trinomial, and we're going to end up with the two separate binomials. All right. So I'm going to give you guys a format, okay? We usually are given the format of, that's not what I wanted to say. You guys remember when we worked with slope-intercept form? We did y equals mx plus b. We talked about what m meant, what x meant, what b meant.
Yeah. What?
Watch yourself, Henry McEwen. I see you. You have mischief in your eyes. Okay. We talked about the basic structure. So that's what we're going to do on the top part of this page. I'm going to give you the most basic structure that factoring could look like. Okay. So in here, we're given the basic structure of a trinomial. So we have ax squared plus bx plus c. So a and b are coefficients. And c is just a number by itself. When it's a number by itself, what's the technical word for it?
Junction.
Nope.
Constant?
Constant, good. So c is a constant. Its value doesn't change. Okay. So what's going to happen now is we're going to be using this side structure to find factors of c, okay? So this end term, the constant, is also going to go here, and we're going to find factors of whatever that constant is. All right, so again, I am just giving you the structure here. So anything times what equals itself?
Anything times 1.
Anything times 1.
Do you have that quiz that we took?
It's in my dorm room. I'll bring it back tomorrow. Bring it in tomorrow. Okay. I know. I'm sorry to let you down. Okay. All right. So we have 1 times c, and then we're going to list any other factors that we need for c also in these columns, okay? And we're going to find the sum of them right here. So again, I'll practice this more specifically with you in the next problem. But anytime we want to take a trinomial and we want to factor it, find the factors of it, we want to break it up into its two binomials, its factored form. And because we're going to work here with a trinomial where a, and we're going to add this to the title, okay, so we're factoring where a is equal to 1 and only 1. And in a moment, you'll see what that looks like and what I mean by that. But the two binomials we're going to end up with are both going to have x at the beginning of them. Because x times x gives us x squared. So we need those x's in the beginning. And the signs are either going to be addition or subtraction in between, and then we'll have a number that comes from the factored list as the second part of the factored form. So again, it should still be a little confusing because we haven't actually done an example yet. Essentially, that's what it's going to end up with. All right. So let's do an actual example now. So I'm going to scroll down, and we're going to do a problem with the example x squared plus 16x plus 64. So there's our trinomial that we want to factor. So again, you'll notice that this term right here, does this term, the first one, x squared, have a coefficient?
No.
Not a written one, but there is a coefficient. What is it?
1.
1. So here, a equals 1. And again, as sophisticated mathematicians, we don't write the 1 because we know it's 1.
I always write the
Which is okay. If you want to and it makes you feel more comfortable with the problem, go ahead and knock yourself out, okay? All right. So which term do I want to find factors of now?
64.
64. So I'm going to put 64 in this top box. So now let's list factors of 64. And if you want to use your factor chart, you can use that. Right? So factors of 64, what's the basic one? 1 and 64. It's an even number, so what also is a factor?
2.
8 plus 8.
2. 8 times 8, you're right. I'm going to put that one, I'm going to skip one, because there's one that's bigger than 2, but smaller than 8.
36. 32.
4.
4. I'm going to do the numbers that are smaller than 10 on this side, but you're not right. I mean, not wrong, okay? So 32 times what a set equals 64?
2.
2. So we have 32. 4 times what equals 64? 16. And 8 times what, Henry, equals 64?
8.
8. You guys ever heard that riddle? He ate and he got sick at 4, so 8 times 8 is 64. That's always happened.
It's not a riddle.
You're right, it's not a riddle, it's a saying. Anyway, okay, so now what we want to do is we want to find factors that have a sum of this middle term. I also forgot to add the x here, so it should say 16x. So if you guys could fit in that x right there, I did forget to write that. Okay. So when we add these, the terms, it should equal 16. So what's 1 plus 64?
65.
65. What about 2 plus 32?
34.
34. 4 plus 16 is?
20.
And 8 times 8, or 8 plus 8?
16.
Is 16. Good. So right now, these right here are the terms that I'm looking for, okay? I'm going to use those two factors to make my binomials. So now I'm going to move down here. And we have x and x, because when we go to double distribute or use the box method, x times x is going to give us our first term of x squared. And I'm going to use these two terms to become the second term in each of my binomials. So I have plus 8 and plus 8. They're not always going to be the same. Okay? Alright. And I also want you to draw an arrow to 16 with a little note that says factors should add to b, the b value. I'm going to mark, Henry,
Yeah.
your homework.
I'm going to go.
So you're going to do these next two problems. The first one is already done for you, okay? So you're going to do these next two problems. I put an X up. Next two.
All right. Be able to do it.
Why not?
I don't want to.
Okay, that's different. Want and can't are different.
Yeah,
okay?
I can't because I don't.
You're so funny.
Go.
All right. So this actually is going to be in-class practice that we're going to do together just to practice the skill one more time. But this is also going to be your homework, okay? So right now, it's only 2:48. So instead of having you start the homework in class, we'll do some in-class practice. We'll finish the front side. Then we'll play either a Kahoot.
Without me?
So we won't have homework tonight?
You will have homework. Yeah, but we're not going to do it in class.
Right.
Okay?
Ooh.
We'll probably play Kahoot because now we have an odd number.
Oh, yeah.
Joseph?
He turned like 1,000 and then
Are you on the ball?
Sure.
Bye, Henry. Good
Oh,
luck.
you're a crossword.
Okay. So again, we're gonna practice using this structure again on this sheet. We're gonna do the front side together. Okay.
And the back all from above.
Not all. No. We'll see how the front side goes. All right. You'll notice the directions got cut off a little bit. So it says directions, write each expression in factored form, okay? We're going to do exactly what we did in the notes. And the first one has already been done for you. So you were given a trinomial that said x squared plus 6x plus 8, okay? So our last term was brought up here to the side where we have our graphic organizer. All right, and now we listed factors of 8. So we had 2 and 4, 1 and 8. And we wanted to find the one that made the sum for 6, because those are the two factors that we're going to use. So, 2 and 4 obviously get carried down here. So now we're going to do this next one, where we have x squared plus 10x plus 25. Which number is going to go in our factor box?
25.
25.
What time is it?
You okay, Sue?
Yeah.
Okay. All right. So let's go through the factors of 25. Someone give me the first set. 1 and 25. 5 and 5. Those are actually the only factors. Do any of those sets of factors equal 10 when they're added?
5 and 5.
5 and 5 equals 10. Good. And 1 and 25 obviously makes 26. That's not it. So I usually circle the set of factors that make the middle number. So now we have x plus 5 and x plus 5. This one also happens to be the same, although, like the one above it, the constant terms and the binomials are not always the same. What I do want to do right now, though, is I want to pause on this problem, because I want to show you that when we multiply them, that they, again, come out to be the original trinomial. So, do we want to use double distribution as a method or the box method? Box method? Okay. So, if I was doing this on my own, I would draw a box, split it into 4 parts. And again, I'm going to put x and 5 on the top and also on the side because those binomials are the same. So, x times x equals?
X squared.
X squared, pretty easy. 5 times x is? And we have that twice. 5 times x again is 5x. And then the last box, 5 times 5 is 25. What do I have to remember to do with these 4 terms?
Add the 5.
Combine like terms, good. So we have x squared, highest exponent first. 5 and 5 makes 10x. And then add 25. Okay. So again, you end up with the same trinomial you began with. So let's continue on. Let's do one more together, and then I'll have you do the next 3 on your own. All right. We have x squared plus 12x plus 32. What's going here?
2.
Please create your own list of factors for 32. I will make my own. Also finish the sum side.
I'm confused on this one.
So I'm not on that one right now. Getting ahead of me. All right, everyone have their list of factors for the third one? Yeah? All right. So here's my list of factors. I found the one that adds to 12. So now I'm going to make my 2 binomials. So in one of them, I'm going to have x plus 4. And on the other one, I'm going to have x plus 8. And actually, I do now that Asa says that, I do want to take a look at the middle one on the far right, the one that says x squared minus 2x minus 24. What's different about this one? There's negatives on 2 out of the 3 terms, okay? So when we do this, we have to list factors that will still multiply to make a negative, right? So what am I looking for factors of? Negative 24. So I'm going to put negative 24 here. So one of the 2 numbers for factors has to be negative. However, when I make this list, I'm not going to write any negatives right off the bat because you don't know which number is going to be the negative. So we have 1 and 24, obviously. What else multiplies to make 24?
3 and 8.
3 and 8. What else?
4 and 6.
4 and 6. What else?
6 and 4.
2 and 12. I think that's it. Right. So now, again, we want to keep in mind that we want to make negative 2.
You subtract them.
So you will be subtracting one of them. Which one of these sets of factors will make negative 2 based on how the sign is?
4 and 6.
4 and 6. Which one is going to be the negative number?
6.
6. So I'm going to put a negative sign in front of 6, and I know that that's going to make negative 2. So you'll notice that I don't even fill out these sum boxes yet until I think about which 2 numbers are going to make the negative middle term. Okay. So again, in my parentheses though, I'm going to have x's, and then I'm going to have x plus 4, because that's our positive factor, and then x minus 6. So the negative sign is going to turn into a minus sign, right? So what I would like you to do now is you're going to do the top one and the very bottom one on that front page.
Are we picking 2 from the sign?
Why 2?
I don't know if you assign Henry too.
That's true, but Henry's also missing part of the lesson, so he doesn't get to practice with us as much.
Alright.
Why don't you start doing 2 on that side, though, and then we'll see how you do.
Alright.
Okay.
Nothing.